Alright, so today we're going to be talking about the empirical formula. Basically, what this formula shows is the smallest whole number ratio of elements in a compound. So there's multiple steps to this, but basically what you do is you take the percentage of the element that you're given, you assume that there's 100 grams of the element to make things easier for yourself. You convert the amount of grams of that element to amount of moles, and then you take the moles of all the elements in the compound and you compare them. You take the smallest number, and that smallest number is your base. It's like your 1, right? And then every number that's bigger than that, you would divide it by the smallest number so that you can get whole numbers and ratios and stuff like that. So let's say, an example problem. Let's say we've got some compound that has 23.3% magnesium, 30.7% sulfur, and 46% oxygen. So like I said, we're going to assume that there's 100 grams of each of these because that makes the conversion really easy. 23.3% of 100 is just 23.3 grams. 30.73 grams, and 46.0 grams, right? So now that we have that, we're going to use this little handy-dandy molar mass to mole conversion thing, and we're going to take our molar masses and convert them. 23.3 grams for 1 times 1 mole, and then at the bottom, we have the molar mass as dictated by our periodic table of elements. So for magnesium, it's 24.305 grams. And then we want to divide that. Let's see, I did it up here. That is 0.958 moles, about. Around it a little bit. And then sulfur, you do the exact same thing. 30.7 grams, 1 times 1 mole. Then the molar mass of sulfur is 32.066. And that is 0.9574 moles. Then last but not least, we've got our oxygen. 46.0 grams over 1 times 1 mole, all over 16 grams, is about, let's see here, 2.875 mole. Cool. So now that we have those values, we want to find our smallest number. We want to find our base value, our 1, if you will. So I'm seeing here that the 2 molar values here for magnesium and sulfur are basically the same thing. Now, keep in mind that with empirical formulas, you want whole numbers, right? So if they're relatively close in numbers, like you could say 0.95 for both of them, these are both going to be 1, right? So there's only going to be 1 magnesium atom and 1 sulfur atom in this compound. However, for this oxygen over here, it doesn't match up with the other 2, right? So what we're going to do, down here at the bottom, magnesium, we've already said that this is going to be about 1. And then for our sulfur, we're going to say this is also about 1. And then for our oxygen, oh, magnesium is Mg, my bad. For our oxygen, we have 2.875, and we're going to divide it by the smallest number, which is 0.9, yeah, I guess I'll say 5. Alright? And then once you divide, you're going to want to round it either up or down, depending on what you get. See, I got 3.026, so it's pretty safe to assume that you can round to 3. Because you don't want something like, oh, there's 3.026 atoms of oxygen, right? That's just, like, what does that mean? So then what we can do is we can simplify all of this to just one compound without all these numbers here. So we've got our magnesium, and we only have 1, so it doesn't need a subscript there. We've got sulfur, a sulfur, and it's only 1, no subscript, and then oxygen is 3. So that is our empirical formula. We've got MgSO3. And that's how easy it is to find empirical formulas. Ooh, it's the end screen. Click on one of these links to be directed to that playlist. And don't forget to subscribe!